Okay, so this is basically the Excel paper. Uh,
Okay.
this is question number one. The diagram represents an atom of an element. Use numbers from the box to complete the table. You may use each number once, more than once, or not at all. So obviously, atomic number of the atom. Atomic number of the atom. Do you know what is the definition of atomic number?
Yes, the amount of protons or electrons there are.
Exactly. So what am I supposed to write in this? What is the atomic number of this atom?
It would be three.
Exactly, it would be three. Good. And it would be three. And then they are saying number of shells shown. How
Two.
many shells you can see? Obviously, this is two. And the mass number of the atom. Mass number of an atom.
It,
Mass number means the sum of proton and neutron, right?
yeah.
So it
So
should be
7.
exactly because we have one, two, three, four, five, six, seven. So because in the nucleus we have protons and neutrons, so you are going to sum it up, and then that would be the mass number. And number of protons in an isotope of this element. Number of protons in an isotope of this element. Obviously, you know the definition of an isotope.
Same number of protons, different.
Exactly. So obviously it would be three again.
Yeah.
Group where the element is found in the periodic table. How can we confirm like where is the position of this element?
The number of electrons it has on the outer shell.
Okay, so how many electrons?
1, so it will be 1.
So I can say this is from group one, right?
It's lithium, I think. Yeah.
Yes, exactly. Okay. Substances can be classified as elements, compounds, or mixtures. Which of these is the formula for a molecule of an element? Element means it should have the same number of atoms. Element, what is the definition of element? Should have the same number of atoms basically. So,
Well,
so which should be correct?
it will be H2O.
It would be H2 only, not H2O. H2O is not an element. It has the different atoms. You know what's the definition of an element? It composed of the same type of atoms. Same type of atom, remember.
Okay.
And also H2O is a compound, not an element.
Okay.
And this is an atom, not a molecule. They were asking a molecule, remember. This
Yeah.
is also a compound, right? This is your molecule. Which of these is a mixture?
Sodium chloride.
Sodium is a metal,
So
chlorine is a non-metal, which is a gas, which
sodium.
is a molecule.
Wait. Yeah, yeah.
It's a compound, ionic compound,
And that's a mixture solution.
and this is a mixture, exactly.
Isn't it a solution?
Exactly. Solution means that NaCl plus water. It's a mixture.
Okay.
Which method can be used to distinguish, to separate the dyes in the food coloring?
Uh,
It's a straightforward question. Whenever you're going to separate the dyes, so you need to do the chromatography. Chromatography. So
yeah,
it's a separation and also the purification technique.
yeah.
Exactly. Uh, okay. Then a student adds a large crystals of sodium chloride to some water in a beaker and leaves the beaker for a day. The diagram shows the beaker immediately after adding the crystal and after one day. After a day, the student takes a sample from the top of the liquid and tests it to see if it contains chloride ions. The test is positive. Describe how the student should do the test. Include the observation for a positive test in your answer. Basically, they are going to do a test for a chloride. For a chloride. So, for a chloride, you are supposed to take some sort of sample from this beaker, and you are supposed to use silver nitrate. Silver nitrate, that is AgNO3. That is AgNO3, and nitric acid, that is HNO3. So if you get a white PPT, white precipitates, if you're getting a white precipitates, means that chloride is
Is it?
confirmed. So
Yeah.
this is a chemical test for the chloride ion. So always remember, whenever you're going to test for halogens, halogen means chloride, bromide, iodide. So you need to add silver nitrate along with nitric acid. Nitric acid is acting as a catalyst. So then if you can see the different colors of the precipitate, so you will get to know that this is chloride or bromide or iodide. Depends on the color of the observation of that test.
Okay.
Name the process by which chloride ions move from the crystals to the top of the liquid.
Uh, Crystallization.
No, 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 no. They are saying that in your beaker, you had sodium chloride, and ultimately sodium chloride in the form of ions because it is soluble in water, and you have taken a sample from here, and obviously you had chloride ions just like that. So they are saying you have put sodium chloride into the, like you can say, the surface of the beaker, bottom of the beaker, but the chloride ions have traveled from bottom to top. Like what's the name of the process that which chloride ions move from the crystal to the top of the liquid?
Fusion.
Ultimately you will say it is diffusion. Am I right?
Yeah. Yes.
Okay, see this.
The apparatus is used in a laboratory to separate a mixture of liquids before their boiling point. The passage describes what happens when the apparatus is used. Use the words from the box to complete the passage. Can you scroll down? Each word once more than once, or not at all. The mixture of liquids is placed in the mixture of liquids in the flask. During heating, part of the mixture boils.
Basically,
It's like
it's an apparatus for the, you can say, fractional distillation, because you can see this is your fractionating column and this is your condenser. So the passage describes what happens when the apparatus is used. Use words from the box to complete the passage. You may use each word once, more than once. Okay, the mixture of liquids
in the
is placed in this,
in the flask.
in the flask. Exactly, this is a round bottom flask. Okay. During heating, part of the mixture boils and
Column.
passes up the column. That's it. That is fractionating column.
Yeah. Water is used to cool the vapor in the condenser.
Good. Which of these changes of state occurs in the separation?
Separation would be separation. Okay. So it would be go from liquid. It would be aqueous to solid. No, it would be yes, aqueous to solid.
No, no,
Solid to aqueous. Sorry,
no.
liquid to solid or gas. What?
Basically, in the whole process, you are going to heat your sample, and the sample is present in your round bottom flask in the form of liquid.
Yeah.
So when you are going to apply heat to the sample, ultimately the sample would be evaporated and it would become a gas.
Okay.
Also, when the gas enters to the column and then enters to the condenser, so what the condenser does, it converts your gas into the liquid. So finally, I can say that the gas is going to convert into the liquid. So I can say that it's gas to liquid means this is C. Okay?
Okay. Fine.
Yes. See this?
The diagram shows three pieces of iron. A is a piece of iron. B is a piece of iron with a thin coating of zinc. Is a piece of iron with some of the zinc coating missing. Name the processes used to coat iron with zinc. Um, to coat iron with zinc, is it oh, it's like I'm not sure. Is it like oxidation? I don't know, sir.
The diagram shows three pieces of iron. Okay. Then A is a piece of iron. B is a piece of iron with a thin coating of zinc. C is a piece of iron with some of the zinc coating missing. Like you can see over here, the coating part is missing over there. Name the process used to coat iron with zinc, used to especially if the coating is done with zinc, especially if the coating is done with zinc, so that process is known as galvanizing.
Oh yeah, or no, yeah, galvanization.
Exactly. The three pieces of iron are left in a separate troughs of water and exposed to atmosphere for several weeks. Okay. The table shows the appearance of the pieces of iron after several weeks. Apparatus A is covered in a brown solid. B, shiny and unchanged in appearance. Shiny and unchanged in appearance. Shiny and unchanged in appearance.
Okay. What is the brown solid contains hydrated iron oxide? What is the common name for this brown solid? Iron oxide.
Brown solid means that it's rust. It's rust basically. So common name is rust, and the scientific name and the chemical name is iron 3 oxide.
Yeah.
You know what is 3? What is 3? It's iron plus 3. It's a charge of iron in this compound. Since you know that iron is a transition metal, so transition metals have different colors and they have variable oxidation numbers. Each and every oxidation number is going to represents the unique color. So that's why when iron is plus 3, so it would be giving you the brown color. Uh,
Okay.
Identify the two substances that react with iron to form the brown solid. Basically, in easier words, they are going to ask how the things got rusted, like what's the reason, like with whom they are going to react with. And so obviously you will say oxygen. Am I right?
Yeah.
Oxygen is the is one man show. So first of all you have oxygen,
And
or next one,
hydrogen.
no, water
Oh,
from the atmosphere, from the
yes.
moisture. You can also write moisture.
Okay.
You can also write moisture.
Okay.
Moisture, yes. Explain with reference to the symbols in the box why the brown solid does not form on sea. Like why the brown solid does not form.
Why does the bar solid not form?
Exactly, like why it's not rusted. What's the reason?
It's galvanized.
Sorry?
Because it's galvanized.
It's of 3 marks. It's of 3 marks. Okay, and then what you would say?
The oxygen and moisture the atmosphere is unable, as there is a zinc coating, and zinc does not rust.
You know, when zinc is more reactive, if you can see the reactivity series, zinc is above than iron. Zinc is above than iron. So, whenever we are going to compare the two or more metals, like which is more reactive and which is less. So, obviously, we need to see that which one is, you can say, uh, which metal would be losing electron easily. If the metal is losing electron easily, so I can say that the metal is more reactive. And if the metal is not going to lose its electron easily, so I can say that the metal is less reactive. So they are saying it's not rusted. It's mean that you have coated the iron piece with zinc since the zinc is more reactive. So zinc is going to lose electron rather than iron. Zinc is going to lose electrons, and obviously it would be losing 2 electrons since the common charge on zinc is +2. It would be losing 2 electrons rather than iron. So that's the reason iron, like to prevent the loss of electron from the iron to form Fe2 plus. When rusting occurs, so iron is going to lose electron when it's going to react with oxygen. So it's changing from 0 to +3. So if the iron is not going to lose its electron, so how can I say that this iron would be rusted? So, so you can do this by coating with zinc, since zinc would be losing electron instead of iron. So you have to use in your own words. Okay, you have to write in your own words. Okay, number one thing is that I would write uh, zinc is more reactive than iron in the reactivity series. So, zinc loses 2 electrons to form Zn2 plus, and
Okay.
which prevents iron to lose electrons. That's the reason. In this way, the zinc is going to lose electron and it prevents iron to lose electron. So the table shows the formulae of some positive and negative ions. It also shows the formulae of some compounds containing these ions. Complete the table by giving the formulae of the three missing compounds. So what would be the first?
Uh, the first V. It would be CuCl2. CuCl2.
Basically, when copper reacts with chlorine,
C.
remember when copper reacts with chlorine, so uh, it would be forming copper chloride, that is CuCl2.
Yeah, I said that. Yeah.
Exactly, CuCl2.
Okay. And then the next one, it would be NH, NHSO, no, NH2SO4.
Uh,
H,
NH4 2SO4. It's ammonium sulfate. It's ammonium sulfate basically.
yeah,
Okay. Or or copper. No, sorry, iron reacts with carbonate. So it would form
CO3.
uh, iron and then carbonate. You can
Yeah,
see the charge of iron. I would write over there, and I would write the charge of carbonates. Blah blah blah. That is 2, so I would write over here. That's the formula for iron carbonate. Whenever you need to write down the formula, so you can also see the valency. So we always swap the charges. We always swap the charges basically, right? The correct name of the compound with the formula CuSO4 is what?
uh, CuSO4, copper, copper 1 sulfate.
Copper 1 sulfate. No, the charge of copper is +2. The charge of copper is +2. So I would say that it's Cu +2, like copper 2 sulfate. Okay? It's copper 2 sulfate, not 1 sulfate.
Okay,
Yes, because the charge of sulfate is 2. So obviously the charge for copper would be 2. +2 and -2.
okay.
Which of these descriptions is correct for ammonium chloride and for ammonium chloride aqueous? Ammonium chloride solid and then ammonium chloride aqueous. Solid and then aqueous. So always remember the solid one is white because this is not a transition metal. Whenever you can see the transition metal, it would be colored, but it's not. So it's white, it's white, it's white. And ammonium chloride, it's soluble. So when the thing is soluble in water, just like sodium chloride, so obviously you would see a clear solution. So I would take C because solid is white and aqueous is colorless. You would see a clear solution. You will see a clear solution. Remember, that's why C is your correct option. Okay.
Okay.
These tests are carried out on two separate. No, it's not your part. We would be opting those which are going to have your exam. Okay, see this. The diagram shows a blast furnace used to extract iron from its ore. So state the purpose of these reactions in the blast furnace. Like what was the purpose of this reaction in a blast furnace when the carbon were reacting with oxygen to form carbon dioxide? What do you think?
To separate, to
Like,
separate
like what do you think? Is this exothermic reaction or endothermic reaction? What do you think first?
exothermic
How?
because it's releasing air, hot air.
No, 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 no. Since this is combustion, whenever it's going to react with oxygen, so you can say that this is combustion. And obviously, combustion reaction is an exothermic reaction which releases energy. So this reaction is only done to provide to or I can say to produce energy. To produce energy. Since combustion reaction is an exothermic reaction. When carbon is going to react with uh, carbon dioxide, it gives CO, and so state the purpose of this reaction in a blast furnace. Carbon monoxide. Carbon monoxide. What is the What is the function of this carbon monoxide? Remember, carbon monoxide is a reducing agent. Carbon monoxide is a reducing agent. So this reaction is to produce a reducing agent. That's why we are doing this reaction. We have to produce reducing agent. And if you remember, this reducing agent will reduce your iron oxide into the iron. So what am I supposed to write in this? I would say that, okay, to produce the reducing agent.
Okay.
To produce reducing agent. Iron ore contains the impurity silica, silicon dioxide. The purpose of the limestone is to remove this impurity. The word equations for the reactions that occur are calcium carbonate gives calcium oxide plus CO2, and then this is. Write a chemical equation for each of these reactions. They have told you all the things, just you need to write the formula. So equation 1 is saying that calcium carbonate is CaCO3 gives us calcium oxide, that is CaO plus CO2. And equation 2, calcium oxide would be reacting with silicon dioxide. It would be giving you calcium silicate. The formula for calcium silicate is CaSiO3, CaSiO3, CaSi, two oxygen and one oxygen, it would be three oxygen. That's why the formula is CaSiO3, calcium silicate.
Yeah.
And why this is a redox reaction? What do you think why this is a redox reaction? Have you done the redox one?
Yeah, it's because there's oxidation and reduction happening, right?
So you need to mention which is reduced and which is oxidized.
So, Fe is, I think, reduced, I think. Wait. Yeah, it's oxidized. Iron is oxidized and carbon is reduced.
It changes into this.
So
It's a
it,
loss of oxygen. Am I right?
yeah.
Loss of oxygen is what?
Oh, yeah, it's a reduction.
It's reduced.
Yeah.
And it changes into CO2. It's a
It's
gain of oxygen. Gain of oxygen is what?
oxidation.
Oxidized. Since carbon is oxidized and iron oxide is reduced, so that's why this reaction is redox reaction. It's very simple. It's very simple, okay?
Yeah.
Oh, and okay. Polyethylene is a common polymer. It is obtained from crude oil by fractional distillation, cracking, and polymerization. The passage is about the fractional distillation of crude oil. Use words from the box to complete the passage. You may use each word. The crude oil is heated so that the crude oil heated so that vaporization, vaporization occur. The column has a temperature gradient. You know, temperature gradient. The column separates the thing on the basis of their temperature. Let's suppose you're having alcohol, you're having diesel. Since the boiling point of diesel is higher, it would be separated first, and the boiling point of alcohol is lower, that is 78 degrees Celsius. It would be separated hereafter. So it depends on the temperature gradient. The compounds in the crude oil pass up the column and condensation occur. If you remember, like before this question, we were doing like liquid to gas. Why this was liquid to gas? Because in every distillation process, first of all, you need to produce the vapors, and then you need to condense the vapor into the liquid form. This is how we can separate the different things on the basis of the boiling points. depending upon the boiling point of each fraction. Depending upon the boiling point of each fraction. Remember, you need to know the procedure for the fractional distillation. It would be very easy for you. So it's related to organic chemistry. I'm not going to do this. So okay, this is also organic chemistry. This is you haven't done so far, and you haven't done so far. Exothermic, endothermic. You didn't do this. And exactly, you've done the periodic table. Okay, bromine, chlorine, and iodine are elements in group 7 of the periodic table. Place ticks and the boxes to show the three correct statements about the elements in group 7. Yes, what do you think?
Um, Bromine, iodine are elements in group 7 of the periodic table. Place ticks in the boxes to show three correct statements about the elements in group 7. The elements can be attained by electrolyzing molten metal halide.
Metal halides. Like, what did they mean? They mean that whenever you have sodium chloride, so it's a metal halide. When you have calcium bromide, it's a metal halide. When you have barium iodide, it's a metal halide. And if you are going to separate the metal halides, so you need to electrolyte them. So yes, this is correct. Yes, this is correct. You can do electrolysis for them. Then the elements with paler colors are lower down the group. Paler colors. If you remember halogens, if you talk about the halogens, so what do you think? What is the trend in color? If you're going down the group, so the color becomes darker or the color becomes paler. What do you think?
Uh,
You
color
need to know this, otherwise you won't be able to do this question.
darker gets darker as you go down the group.
Exactly, it gets darker. So means they are saying that the elements with paler colors are lower down the group. Is that correct?
No.
Exactly, it's wrong. The boiling points decrease down the group. Decrease down the group.
Uh, yeah, that's correct, I think.
That's correct.
No, no. I did. Okay, yeah, 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 it's wrong.
What
It's
are you
wrong.
saying?
It's
It's wrong.
yes, it's
Boiling point increases down the group. Fluorine is a gas, chlorine is a gas, bromine is liquid, iodine is solid. So boiling point increases down the group. This is wrong. Now you can see the fourth statement. What they say.
uh the elements form covalent compounds with other nonmetals. Uh, that's not right. I don't think not right now.
You know, it means that you have halogens that are, they all are non-metals. They all are non-metals. So they are saying that when these non-metals gonna combine with other non-metals, so are they going to form covalent or ionic? For sure, they would be forming a covalent compound. For ionic, you need metal. You need metal. But when two non-metals are going to combine with each other, they would be forming covalent. So obviously, this is correct. Am I right? Yes
Yeah.
or no? Good. Their molecules contain two atoms. Okay, good. That's also correct. They all are diatomic. They all are diatomic.
Yeah.
F2, Cl2, Br2, I2, At2, they all are diatomic.
Yeah.
And they are saying all are gases. No, no, no. Iodine is solid. Bromine is liquid.
Yeah.
This is incorrect. Okay.
Yes.
Write a chemical equation to show the formation of the salt potassium chloride iodide from a metal and a halogen. I need to form potassium iodide. Can you tell me the formula for potassium iodide?
It would be K. It would be K2I.
No, man, it's
Wait, no.
Ki. The charge of iodine is 1.
Oh yeah.
It
Sorry.
would be reacting with K and I2. To balance this equation, I would be writing this. Okay?
Yeah. Yeah.
Um, hydrogen chloride is dissolved in methyl benzene with a piece of magnesium ribbon. Okay. Explain observations. First of
Uh,
all, you can tell me this.
at room temperature, hydrogen chloride and hydrochloric acid chemicals be represented by the formula HCl. Insert the symbol after each formula. Uh, okay. Hydrogen chloride would be wait.
So hydrogen chloride would be what?
What does it mean? Oh, the state. Oh, it'll be liquid, aqueous. Oh, but aren't liquid and aqueous the same?
Sorry, it should be gas. Should be gas, and it is aqueous. Hydrogen chloride, hydrochloric acid. There is a difference, okay? There is a
Yeah.
difference. At room temperature, hydrogen chloride and hydrochloric acid can both be represented by the formula HCl. Insert the state sample after each formula. So you must know this. This is general knowledge. Hydrogen chloride is dissolved in methyl benzene when a piece of magnesium ribbon is then added to this solution, means that which contains HCl. There is no reaction. Why
Yes.
there is no reaction? When water is added to this mixture and it's shaken, a reaction occurs. Explain the observation. You have added HCl, you have dissolved HCl in methyl benzene. You have dissolved HCl in methyl benzene. Now they are saying that there is no reaction. So when you have added this, but when you have added the mixture in water, then they are saying the reaction occurs. So now they are asking observation. So ultimately, when it would react with HCl rather than methyl benzene, it is dissolved in water, that is aqueous. So you will see that hydrogen gas is released and you will see the bubbles due to the formation of hydrogen gas. This is your observation, okay?
Yeah.
And also, this was solid. So when the reaction occurs, so the solid disappears frequently. So the
Okay.
solid would disappear because it's going to react to form the salt, to form the product. Ultimately, it would be decreasing in amount. It would be decreasing in amount, right?
Yeah.
So, and it would be forming what? Magnesium chloride.
Yeah.
This is your salt.
Okay. Explain which test gives the result that cannot be used to compare the reactivities of halogens. Uh, is it bromine? Actually, no. No. Explain which test gives a result that cannot be compared to the reactivities of halogens. Uh,
Obviously, this is reaction 2. Obviously,
how?
this is reaction 2 because they are the same thing. How you are going to compare the reactivity? They are same. They are chlorine. So, like between what you are going to do a comparison. Like obviously, you need to do comparison between the two different halogens. Let's suppose you have chlorine and bromine, bromine and iodine, iodine and acetylene. Okay, so they are the same thing. So you will write that it is test 2. It is test 2. So why? As okay.
Yeah.
See this? Which observation shows that a displacement reaction occurs in test 1?
Uh,
Like in this test, bromine is reacting with NaI.
yeah.
NaI, bromine, bromine. Oh, ho, 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 ho. Bromine is going to react with NaI, and bromine is more reactive. It would be displacing the bromine. So, what do you think? Like, what would be observed?
You would see this you would see a reaction, maybe like the change in color because due to bromine being
What's the
uh
color of this? What's the color of this?
blackish purple.
Exactly. So the solution becomes darker because iodine is going to produce. Am I
Yeah.
right?
Yes.
Write an ionic equation for this displacement reaction.
Okay. Ionic equation. So wait, what does it mean by ionic equation?
The overall equation in which the ions are involved only. So you are going to add them together.
Yeah.
You are
So
going to add them together and it would be producing this.
yeah, 2AT becomes 2Cl plus AT plus 2.
Exactly. Yes.
Uh, okay.
Plain with reference to the approximate species and to electrons. Why this reaction is described as a redox reaction.
Because there is a loss of there's a loss of electrons and loss of oxygen, meaning that there is a redox reaction taking place.
Basically, it's going to gain electron.
Oh,
So it is reduced and it's gonna lose electron. Okay, that's why
yeah.
this is a redox reaction. Yes, he makes two mistakes. What's the mistake, man?
Uh, okay, so delocalized protons are not supposed to be there. It's supposed to be delocalized electrons.
No, man, no. You can see
It's
this should
deloc.
be an electron.
Yeah, and it should be delocalized electron. Oh,
What
wait.
would you write? What would you write?
The positive cations would be. Wait, what? A student draws a label diagram in magnesium metal, so it would be delocalized electrons, and instead it will be in a sea of delocalized electrons with cations instead of. It would only be positive
This is
cations.
your first correction, and the next correction would be okay. Uh, they are saying delocalized protons.
Yeah. So
So replace. Okay, replace protons. Why magnesium metal is malleable and a good conductor of electricity?
it is so magnesium is in group two. It is an ionic compound which are good conductors of electricity. It is malleable because it can be layered. The layers of wait, I don't remember how it can be malleable, but it's something to do with the layers and electrons sliding over each other.
Basically, you can see every metal has this structure, which is called a giant metallic lattice structure. Giant metallic lattice structure in which you can see the layers. So the layers are going to slide over each other. That's why we can say that the metal is malleable, and always you can see that in every metal there is a free electron. So the electron would be moving around and it's the whole lattice structure. So that's the reason I can say that the metals are good conductor of electricity. Okay?
Okay. Yeah.
Yes. Or.
Sir, I have another class in about 1 minute, which I need to join.
Sorry?
I have another class I need to join in like 1 minute.
Okay,
I
okay, okay.